Previously we have discussed about how this pixel and vertex shader works. Today we will see how can we use vertex shader to deform an geometry on GPU. To simplify the discussion and for better understanding, we will develop a push deformer using HLSL vertex shader. We can see the push modifier inside 3ds Max to deform a geometry object. So like here, the push modifier here. Push modifier inside 3ds Max is calculated using CPU. But in real-time game, if we can do the same push deforming using vertex shader, it will free up CPU for other aspects of game like gameplay, AI calculation. Thus dividing the whole job between GPU and CPU will give us better performance. As we know, after developing the shader in NVIDIA FX Composer, we can load it back in 3ds Max or inside in our game engine. Basically a vertex shader performs per vertex processing such as transformation, vertex displacement, skinning, etc. and also calculate per vertex material attributes. So first see how this push deformer works. So here I have a torus object inside 3ds Max. I also have applied push modifier on it. Now if I change the push value, you can see the geometry is deforming by this push modifier. Now we'll go back to our NVIDIA FX Composer. Inside NVIDIA FX Composer we have similar kind of setup. I have a torus object here as well. So and in the material you can see I have applied a push blend material on this object. So and this push blend material is basically using our push blend FX shader, which is basically a blend shader. Now if I go to our push blend, you can see it is a standard blend shader. It has say like it is taking the parameters like the lamp position, it's taking the diffuse color. So we can, if we change the color, you can see the diffuse color gets changed. It's also taking the ambient color. So if we change the ambient color, it will affect the ambiency. And we have other material related thing, but this time we are mainly interested about the vertex deforming. So we'll go back to our push blend FX shader, vertex shader area. So here the vertex shader get calculated, the app data struct in is coming here, and in this area basically we are getting the from our app data we are getting the positions of the vertex, and we are giving it back by the vertex output struct. So whatever the vertex position we are getting here, we are giving back as a vertex output struct after multiplying with world view projection matrix. Okay, so now we'll convert this simple vertex shader to perform our push calculation. To do that, what we need another parameter, so it can get displayed on this property grid. We'll need push parameter here. the default value what we want is 0. UI widget, and it will be slider, minimum and maximum for this slider. UI mean is say like -1.0 to UI max is 1.0, and step value for the slider 0.01 say, and we need a name for the slider which get displayed here. So the name is UI name push factor, and that's it. So we got now push. If we compile the push blend effects, now we'll get updated push material. Change it, you can see now we got -1 to 1, and we also have 0.01 step, but when we are changing it, it has no effect right now. Now if we come back to our vertex shader, what it is doing right now, so this in dot position, we need to change this portion. So when we will change the input dot position, it will affect the vertex position, what basically we need to do for the push deforming. So let's create another variable here, which is our final pause. Now after getting the final pause, what we will do, we know our in appdata, which is appdata struct. Appdata struct is giving us the position of the vertex, so we'll access that position. So in dot position plus, now we'll do the push calculation. What we will do, we'll do a multiplication with the normal of the vertex. So in dot normal, in appdata also has a normal. So in dot normal, and we will multiply with the push value coming from the parameter we have just created. So that's simple. So if I now rebuild it, you can see everything is fine like previous. So if I go back to my viewport, you will see we got the push factor here. Now see, if I change my push factor, see what is happening. We are now getting the push, but this push is done through GPU by the vertex shader, and it is completely calculated by our GPU, which is cool. So see, like this way we can create more vertex deformer. We can animate them. We can use in our gameplay, which is pretty cool and also very handy.